I'm Alaisha Alexander, a data engineer at Aimpoint Digital. Let's get right into talking about using Snowpark and Dataiku. If you're familiar with Dataiku, you already know it has a user-friendly and easy-to-use interface of recipes that allow you to transform and model data. Dataiku flows make it intuitive and simple to interact with and visualize your data. If you prefer to work in Python, Dataiku has Python recipes that allow you to add your own code to the flow seamlessly. Snowpark is a developer framework that brings native SQL, Python, Java, and Scala support to Snowflake. This is just to say that you can get the elastic and secure data processing of Snowflake when using these languages. So in this video, we'll be explaining and exploring how to use Snowpark and Python in a Dataiku flow and reviewing the advantages and disadvantages of doing so. We'll start by covering Dataiku recipes and reviewing the performance both on the DSS engine and in database. Next, we'll review Python recipes. Then we'll demo using Snowpark in Dataiku. Finally, we'll review all the demos and talk through the key advantages and disadvantages. As mentioned, we'll first start with the Dataiku recipes. Before we delve into the actual recipes, let's take a closer look at the data we've already prepared for the filter and join. We have two types of datasets here: clients and sessions. The clients dataset gives us a plethora of information that was randomly generated about individual clients. This dataset has about 5,000 distinct rows of client information like names, client ID, emails, prescriptions, credit card information, etc. There are about 19 columns of data in this prepared dataset. The sessions dataset only has 3 columns. These columns give information about the scheduled session and a client ID. There will be 3 of these sessions datasets of varying sizes. The small dataset will have 20,000 rows, as we can see here, the medium 1 million, and the large 20 million. With this recipe and our subsequent computations, we'll be joining the client's dataset to the scheduled session dataset. Basically, we'll be joining client information to each individual session. This Dataiku recipe will take the prepared clients and sessions datasets and perform a left join based on the common client ID field. This recipe can be easily reused with other datasets that have a common field, making it an easily scalable solution for data preparation tasks. In a sales setting, this recipe could be used to join customer data with their purchase history to identify trends and make data-driven decisions for marketing campaigns. In healthcare, it can be used to join patient data with their medical records to track their medical history and identify potential health risks. Before we hit run, right here, let's take note of the execution. We can see that this can run in database, and in this case will be a SQL query on Snowflake, or we can run it on the DSS engine. We'll be running this as a SQL query on Snowflake. We'll hit save and then hit run. We will do this non-recursively just to build only this dataset. And voila, we will then have a filtered join final dataset using a Dataiku recipe. So let's go look at the job details so that we can see the time it took to process the job and take a look at that for the 3 datasets as well. Here we are with the job details. So we can see the total duration of the job was about 8 seconds, but we're only really interested in how long the actual activity took. The activity would basically be the recipe that we ran. We did this in database, and we can see here that it took 4 seconds. We recorded the average activity time for the various sizes for both in database and the DSS engine. As we can see here, from an in database session, this activity took about 5 seconds, but in the DSS engine, the very same activity took about 14 seconds. So when we look at the average time for the DSS engine versus in database, we can very clearly see that running it in database using Snowflake is significantly more efficient. You may notice here that the large for the DSS is not included. That's because it took upwards of 48 hours to complete, so we did not include it in this particular case. After we review Snowpark, we'll also actually take a closer look at cost. executing these activities in Snowflake has such a clear increase in performance. We can see pretty clearly that running it in database using Snowflake is significantly more efficient. Though Dataiku is always running, executing these activities in Snowflake has such a clear increase in performance. After we review Snowpark, we'll also take a closer look at cost. Let's move on to the Python recipe. Dataiku enables companies with data scientists or modeling focused teams to streamline their data preparation and processing tasks, especially if they primarily work in Python. With Python recipes, teams can leverage their existing expertise and write reusable, scalable code that is tailored to their specific needs. Dataiku also provides Git integration, which can simplify workflow even further, allowing teams to easily version their code, collaborate on development, and integrate with other tools in their software development pipeline. For the Python recipe, we're going to jump right in and explain the code that we have. After we read the recipe inputs, we're doing our left join here on line 40. And then here on line 42, we're selecting the list of columns that we want, and then we're making sure that it's distinct. So to do that in Python, we've utilized methods of the pandas data frame. You'll also notice that I'm setting this up as a Python function named joinFilterDistinct_py. This is so that it can be easily reused. This is set in a library and available to all Python recipes in this flow, which makes this recipe I create very, very easily reusable. Before we continue to move on, let's also take a look at the adjustments to the Python function for the large dataset. Unfortunately, due to its size, this dataset cannot be converted to a data frame that can be held in memory. It's simply too large. So in order to address this, the dataset has to be joined in chunks. Here you'll notice this entire section just for chunking. In this particular example, we'll have to have that parameter in our function so that we can do the chunking here in the function. Here, instead of bringing the entire session's dataset into a data frame, we iterate through it in chunks and join the relevant client data in the same way we've done before. So we still use that merge and we select our columns and also ensure there's no duplicates, exactly how we've done before. We then write that chunk to the output and redo this again and again until all the chunks are written. So now, no matter the size, we are still using the same function, and we're able to reuse this as often as we need to for all the different size data sets that are needed. It's important to note that Dataiku provides customizable and reproducible environments for Python recipe development and execution, where teams can specify the Python version, packages, and dependencies they need to run their code effectively. So now that we have the library with our function and everything set up, we can then go validate and run this code to produce our dataset. Here in the flow, we have a Python recipe already set up. So let's go ahead and check that for the function, like I mentioned. As you can see, we have our needed import from that library with the function that we've created, all the inputs that we need as well as the selected column, and we can just run this function. All that's left to do is validate and run this here so that we can create that data set in the flow. Awesome. So why don't we go look at the job details so that we can actually see the time that it takes to process a job like this for all three data sets. As I mentioned before, here are the average times, not just for Python, but also the previous ones from Dataiku and DSS and also in database, just for comparison. As we can see, Python performs similarly to the small in DSS and does outperform the actual DSS engine when it comes to Dataiku, but it doesn't seem to come anywhere close to what can be done as a Snowflake SQL query. So I think it's pretty well established performance-wise that doing these as SQL queries within Snowflake is pretty ultimate. Let's move on to the Snowpark computation. As I mentioned before, Snowpark is a developer framework that brings native SQL, Python, Java, and Scala support to Snowflake. So we'll be using Python. Snowpark allows us to have a direct connection with Snowflake using Python. So unlike the Python code, which copies the dataset into a pandas data frame, we'll be directly referencing the Snowflake tables here. Because of this, we won't have to worry about chunking. You'll notice that we just initiate Snowpark right here, read our inputs, we do our join, select and distinct all in one line, and then we write the outputs directly into Dataiku. When we go to look at what we're executing in the flow, Very similar to the Python recipe. We're just referencing that function. We're importing it, bringing in our inputs, and then referencing the function directly. Because these are references and not data frames that are held in memory, it should run just like it would if we had done it in Snowflake. Excellent. So let's go look at the job detail so that we can see the time it took to process this job. And then we'll take a look at that for all of the three data sets, the average times. Here we now have a full comparison of the time that it took, specifically with Snowpark there at the bottom, compared with Python, Dataiku in database, and the Dataiku DSS engine. As you can see, it's pretty comparable to what's done with Dataiku in database, essentially because we're still using Snowflake here. It is also important to note that for in database as well as the Snowpark computation, we are utilizing the same connection. So this is not a Snowpark optimized warehouse. This is a small warehouse in the same Snowflake connection. Now that we've seen all three, let's review their reusability, cost, scalability, and performance. For reusability, we'll be examining the ease with which each method can be reused or applied to different datasets or scenarios, promoting efficiency and saving time in data analysis workflows. Starting with the Dataiku recipe, we can see exactly how easy it is to copy the recipe and use it with another dataset. We'll have to specify some key information to successfully do the transformation, but the left join, selection of columns, and distinct aspect are all still there. In fact, we can also see that this is true for the Python recipe and the Snowpark recipe as well. Dataiku makes it very easy to copy existing recipes, and with a few changes, it's easily reusable for all methods. Let's move on to cost. This will be the consideration of the financial implications associated with utilizing each method, including compute time and resource consumption. Since DSS is done in memory and RAM, there is not an additional cost to its use or the use of the Python recipe. Doing in database or Snowpark does have a cost and requires a connection to Snowflake. Snowflake has a credit system. So you'd purchase credits and then assign warehouses and run queries on those warehouses to utilize your credits. Shown here is the cost in credits per hour of using particular warehouses. Snowflake does have Snowpark optimized warehouses, which are useful if utilizing Snowpark with user-defined functions or other more specialized features of Snowflake. So let's say we purchase credits at $3 per credit. With a standard medium warehouse, that'd mean our cost would be about 20 cents a minute, since use is rounded up to a minute once the warehouse is on and running. For a Snowpark optimized warehouse, that cost would be 30 cents per minute. In this demo, we've used a small standard Snowflake connection for both in-database and Snowpark, and none of our queries ran longer than a minute and usually ran one after the other. Assuming a similar credit cost, each query was less than about 10 cents per query. We'll evaluate scalability and performance together. Scalability is how well a method can handle increasing data volumes and complex computations without compromising performance. Performance is the evaluation of how efficiently and quickly a computation method processes and analyzes data. We can see clearly that in-database and Snowpark, due to the Snowflake connection, are remarkably scalable when compared to Python and the DSS engine. Additionally, their performance does outweigh that of the DSS engine and Python considerably. Keeping all this in mind, we recommend utilizing the Dataiku recipes, but running the recipes in database. You keep the performance of Snowflake with a cost you can manage through choosing a warehouse that works best for your needs with the Snowflake connection you create, while also maintaining the ease of use, reusability, and scalability of the Dataiku recipes. Snowpark is particularly useful for user-defined functions in Snowflake, and utilizing it instead of pandas for teams that already have a predefined Python structure also allows you to take advantage of the computation offered by Snowflake. Overall, we can clearly see how well Dataiku and Snowflake work together. If you are looking for a powerful, scalable, and user-friendly solution to manage and analyze your data, Dataiku and Snowflake will fill that need. With Dataiku's visual interface and advanced machine learning capabilities, and Snowflake's cloud-based data warehousing and analytics platform, you can unlock insights and drive results for your business. Plus, with seamless integration between the two, you can streamline your workflow and get the most out of your data. If you want to learn more about Snowpark, we have additional videos to help get you started. Here, Christopher Marlin reviews how to create data frames, the concept of lazy execution, and how to utilize methods. If you're interested in learning more, stay tuned, like, subscribe, and feel free to visit aimpointdigital.com. Thanks for joining.